Hello, welcome to the final CJP safety video podcast dealing with landing performance. Today, we are going to summarize what we've discussed so far, as well as create a workflow that will let us in the cockpit decide how to calculate our landing performance. Just want to emphasize what we're talking about right now is just performance planning. We will talk later about execution and the proficiency required, stabilized approaches, etc. But right now, we're just talking about deriving the numbers that we're going to use to decide if we are capable of safely landing at a given runway or not. So for our summary and our workflow, we're going to start with dry runways, although this is also the baseline we start with for any runway, contaminated or wet. But for dry runways only, for all of our performance planning, use no headwind benefit. And if any tailwind exists, we want to do the planning as if a 10-knot tailwind component existed. Again, we don't want to plan on taking a benefit for a headwind that the METAR might indicate exists, but at the time of landing may have decreased or changed component. And likewise, we want to be conservative. If we think there might be a light tailwind, we want to imagine that it could perhaps increase up to our maximum as we're landing unbeknownst to us. So we're going to do our planning in the most conservative fashion with the wind. We are going to default to using a 60% safety factor. Remember, that means we could land in 60% of the landing distance available, LDA, declared distance, or our calculated runway times 1.67 must be less than the LDA, unless we meet all of the following criteria. If we have an electronic or visual descent path indicator, so an approach, visual indicator, VASI, PAPI, or avionics allow us to create a proper glide path on a visual approach. Those cases, and the PIC has 100 hours time and type, and the PIC's flown at least 15 hours as PIC in the last 90 days. And then the important point to emphasize here is you also have to feel proficient. Okay, can you hold VREF within 2 to 3 knots, land with minimum float, etc.? There's a lot encompassed here. Of course, we're trying to give you some guidelines to think about. We're not trying to create a formula that will tell you in every case what safety factor is appropriate. Maybe you're landing in an airport you've never been to at night. That might prompt you to a more conservative safety factor, even if you met all the other criteria. Maybe you're landing in a challenging airport with a significant slope in the mountains. That might prompt you to use a more conservative safety factor. So again, we're not trying to encompass every variable, but if you meet all of the above, then our SOPs say we could use an 80% safety factor, or 1.25 times the required distance has to be equal to or less than the LDA. That safety factor can be entered into the iPreflight app. It allows us to pick a 60 or 80% safety factor. The ProLine 21 and the newer Jeep 3000 loads allow us to enter it as the 1.25 or the 1.67. Otherwise, we have to calculate this manually. Okay, we have to use a calculator on our iPhone or in the cockpit otherwise, and determine if we have that safety factor present. Now, for non-dry runways, if we're only dealing with water, no frozen precipitation, just water, our workflow starts like this. We ask, is the runway grooved? If the runway is grooved, then if the rainfall is light or moderate, and the runway condition, if one exists, okay, that's not going to always be reported, but when we say and, that just means if it is reported, is equal to or better than 5, then we would use the wet data from either our app, SESNAV, iPreflight, or the column in our AFM advisory information. If the rainfall is heavy, or there is a runway condition code that is less than 5, then we would use the 1/8 inch water covered data. That is going to be the most conservative column in that water covered field of information. So rainfall light or moderate is considered wet, heavy is considered contaminated, but the runway condition code also has to be considered. Any runway condition code that's presented to you less than 5, we automatically go to the contaminated. If the runway is not grooved, we have another question to ask ourselves. Is the runway asphalt? If the runway is asphalt, then if the rainfall is light and we have a condition code 5 or better, we would use wet data. But the moderate rainfall now pushes us into the contaminated category. And this again is that recommendation from the most recent SAFO safety alert published by the FAA. Finally, if the runway is not asphalt, we looked at concrete runways and how there have been some recent accidents on them. And we looked at some admittedly old data, but some pretty rigorously derived data on the coefficient that we might experience braking on those. So the recommendation is if you have a runway condition code that is equal to or better than 5, then that's legitimate data that would tell us we could use wet data numbers. But if you don't have a runway condition code, or if you have a runway condition code less than 5, or any rainfall, of course, we're talking about, then we would use the 1/8 inch data. Okay, so if we have rainfall and we do have a runway condition code greater than or equal to 5, we could use the wet data. But if we don't have that positive measurement that tells us, or an equivalent braking action report, of course. And we have to be careful with braking action reports, remembering that an aircraft that has reverse thrust might experience different braking than we do, but we could use that as an equivalent. So as we go up this scale, we're becoming increasingly conservative where we make the transition from wet to contaminated data. And then we do want to emphasize again that even the contaminated data is not quite 2x the dry landing distance. And you may recall when we looked through some of the data from the FAA and from NASA, there are certainly circumstances where we might need more than 2x the dry distance. So we're never going to find that in our AFM supplement, and that is where the safety margin comes into play. So if we have a 1.8, 1.9x, but we add a further 1.25 on top of it, or better yet, 1.67, then we will likely encompass that 2 to worst case 2.5x that we've seen. If we're dealing with frozen or a mix of frozen and water contamination, then our recommendation is for a snow or slush condition. We want to use the most conservative contaminant. Now, this is going to vary depending on what model airplane you're flying. Some of the citations, the most conservative column is the 1/8 inch snow slush. For other citations, the compacted snow, we're talking about non-ice, of course, here. The ice is always going to be the most conservative, but we're talking about the non-icing condition. And then for some airplanes, it's actually going to cross over. So some of the citations for some dry landing distance that we enter the table with, one column will be more conservative, but as the dry landing distance increases, then the other column becomes more conservative. So make sure you check both of those. In Canada, if you have a CRFI report, then use the CRFI table from the Canadian AIM. It's available for download because that is going to be more precise. That will give you more precise and typically also more conservative values than the AFM will. And we strongly encourage with anything that is not just water, the use of a 60% safety factor. There is such large variability here that the 80% safety factoring is just not adequate for these circumstances. So we've created a cheat sheet, a knee board. It can be folded in half and stuck in the side compartment on your knee board that summarizes these slides we just went through. We will have that available for download, and we encourage you to use this workflow as you make your decisions on if adequate runway exists.